Hello everyone, my name is Igor from the Gravity Engraving channel, a channel about laser machines and markers. Today we'll look at 3D engraving, specifically 3D engraving on brass. The principle of selecting parameters and templates, how it's all done, how it's formed, where it comes from, and how it's generated, I understand. But for most of you, this will be a complex process that you're just starting to learn. I'm working with the LaserBoss software again. Some use Lightburn, others use Xtool Studio, or the Xtool F1 Ultra or Xtool F2 Ultra machines. So if this is difficult but interesting, there's a beginner's course for laser markers using EasyCAD 2.0, specifically for fiber lasers. If you're interested, I'll leave the phone number in the description, but let's move on. We have an STL file in this format. So this is basically a direct image from this STL file, and we're loading it into ArtCam 2018. In this program, we create a new file, a new model, with a workspace size of 500 by 500 millimeters, which I think is the optimal choice for me. Then we go to Relief, Import, and Import 3D Model. We load our STL file and position it on the workspace as needed. After that, we go back to Relief. Export, export as, save as, and here we select only the BMP format, and then we save our model, which is already saved here. After all that, we transfer everything we have here into Corel. In Corel, we get two images created by Master Andre in Kazakhstan, who makes models like these. The difference between these two left models is the background, while this one is a screenshot of how the STL model itself looked. Our saved model looks very different because we saved it directly in ArtCam in BMP format. I can't say how detailed it'll be. Today we'll test engraving this model as well as these other models. Here, we'll delete everything unnecessary again. So this image and this image will be the unnecessary ones. We need to keep the two images with a black background and a similar image, like the one we made in ArtCam. For a fair test, we'll make them the same size. The height is 108 millimeters. We'll also set the height here to 108 millimeters. I'll leave the phone number for Alexander, Andre. Wait, Andre? I always mix them up. I'll leave it in my Telegram channel, so if you're interested, go check it out. The difference is clear. This one will have better detail, while this one will likely have more depth, but we'll definitely check all of that. So we have the size of our blank. The blank is 30 millimeters high, so I'll set this image to 30 millimeters high, and its width is about 26.5. We're interested in the maximum size, so we'll set this to 30 and this to 30, and everything else will be secondary. To keep it fairly even, 26 by 30. We can basically make squares, or rectangles let's say, set the size to 26 and the height to 30. Press enter, and then we can proportionally scale these squares up to 108 millimeters. Okay, 108, same thing here. We'll set the height to 100.08. 100.08, press enter, then shift drag these squares to our layouts and center them accordingly. And these squares have, well, let's say the option to be placed a level below. So we can give them a black fill, then press shift and page down. That way, we're positioning our squares just a little bit lower in the stack. And there we go. The size is 93.6 by 108 by 108. Do we really need to burn all that empty space and waste our time? Everyone makes their own choice. We could do ovals, circles, whatever you like. Honestly, I'd probably go with ovals here. How is that done again? Let's delete our backing. Keep it simple, and pick some circles or ovals to place within our object. Right-click to color the object, and then position it so it's perfectly centered. And that's how we get our current image. Select the cursor again, shift-click the image, center it vertically, and then crop it. Once it's cropped, we'll go ahead and delete the extra image here. For our oval, press shift and page down, and color it black. Or use the button on the right panel. And we end up with this nice oval-shaped image. We can do the exact same thing with the image on the right. Let's drag our oval over to the right side. There's a little catch here though. Since we saved our previous image a bit larger than the proportions we're using here, we might want to scale it down just a little bit. So instead of 108, let's try making it, say, 100.0. Well, or exactly 100 millimeters, for example. And that'll give us almost the same proportions as we have over here. Same thing, click our oval, shift-click the square, crop it, and delete the excess. And we get a more or less identical image. Actually, it looks like it might have turned out a bit smaller here. Let's make it just a little bit bigger. Let's say 104 maybe? Okay, 104? No, 104, 103 maybe? 103. Let's go ahead and repeat the crop again. Okay, I can't quite grab it. Oval, crop, delete the extra, hit delete, and we have, well, roughly identical images. What's next? Select the image, press Ctrl E, and save it to the desktop. We'll use PNG format again to remove all the extra edges and avoid a white background. Dim Lun. Click Export. Make sure transparency is on, RGB 24 format. Click Apply. The downside is, look what I did, I saved both images. There's no option here to save the images separately. This old version of Corel unfortunately doesn't work that way. Delete one image, Ctrl E again, repeat for Daemon 1, export, yes, replace. Yes, done. Great! Press Ctrl V, now delete this one and repeat the same procedure. Ctrl E, click on it, and type Daemon 2 here. This gives us two separate images for our engraving. Click OK. And now we move on to launching the Laser Emboss program. Launching Laser Emboss, it's going to be entirely in Chinese. It actually runs more stably this way. Click to load the image and select the desktop again. Look for Daemon 1, Daemon 2. Let's start with Daemon 1. Open it up and the image loads. Remember, right, the height of our block is exactly 30 millimeters. So not 35, not 40, but exactly 30 millimeters. So we set the exact same parameter, or we can make it just a bit smaller, meaning the height of our block should be no more than 30 millimeters. Let's go with 29 millimeters. Press Enter, 29 by 20 millimeters. Great. Now let's move on to the fill settings for this block. In the fill settings, we select active bidirectional, meaning calculate all, bidirectional fill density. Let's set the value to 0.008 millimeters. Then click Apply. As for the engraving parameters, we have one small issue here. Since we've set stable parameters for start power, laser off, and everything else for a speed of 3,000 meters per second, we know the optimal engraving power for brass is 60%, with a frequency range between 60 and 80 kilohertz. To get a smoother finish, which means reducing the Q pulse automatically on the JPT50LP, we set the frequency a bit higher and the Q pulse drops. We can only balance the engraving depth by increasing or decreasing the fill density itself, slightly adjusting the frequency range to soften the Q pulse, meaning to shorten it, and then adjusting the power. In our case, the power stays stable, we're not changing it, we've bumped up the frequency slightly and increased the density to 0.08 millimeters. Press F1 and let's go set up our workpiece for engraving and start the process. And now for the most interesting part, who can tell me which image turned out better? The one that was originally created in the height map and accordingly the STL file? or the second one made through ArtCam? Take a guess. Let's start with the second one. Let's go with the second. The pros and cons, well, I think they're obvious to everyone. The structure, volume, relief, it all looks kind of flat, and this was all made, accordingly, directly from... Let's set it up like this so you can see it well. This was all made directly from an STL file through ArtCam, using the height map system. Yeah, so naturally it was chemically polished, then patinated, and then finally polished with felt. And what about the result that was originally done properly and with high quality? The difference is obvious. In the height map, it all looks much better. Yeah, it's a bit dull because I got fingerprints on it, but the relief is more voluminous, more alive, more interesting. And if you even look at the outer part, around the skull, well, here it turns out flatter. Not really structured, the ears are just okay, but here everything has more volume. So draw your own conclusions. Sometimes you need to go to masters who make such cool things. As always, a thumbs up from you, and from me, more goodness and wealth. This layout is saved in our Telegram. The link to Telegram and all other necessary links will also be left under this video. That's it, guys. Wishing you all the best, and bye-bye for now.